Jai Hind students, as you all know that we have covered the mechanical properties of solids. This is the first part of your next chapter, that is the mechanical properties of fluid. And in this chapter we are going to study different terminologies related to fluids, which type of fluid, how the fluids are different, what is the rate of flow in the fluid, and what does actually the fluid means. In this lecture we will also see the what does Pascal's law says and how it is applied to everywhere. Yes, I'm your physics teacher Mukund Manas. So without wasting any further time, let's start with the fluid. So if I say a broad term fluid, it means that I'm talking in terms of both liquid as well as gases, and it is the ability of a material, it's the ability of that fluid which has a tendency to flow, or also it can be also understood from this line that the ability by which a substance that can flow is called as fluid, and it's a broad term. Under the fluid under the fluid we know that there are two main things. First is liquid, and second is solids. Oh, sorry, not the solids, liquid and gases. Though we study gases in a separate chapter that will come in kinetic theory of gases, in that chapter we will only deal with the kinetic theory of the gases, but the ability by which they flow, that comes under this fluid mechanics. It's a very interesting chapter, and if you study it well, you will get a good marks in that also. Liquid in equilibrium. What is this? Suppose I have taken a beaker and filled a water in that. There is a point O. There is a point O which is under this liquid. I have to change the color of my pen. No, it's okay. There is a point O, and by some means that point, the liquid at that point, I'm pressing it downward. So we will get an upward force, that is nothing but the upthrust force. Suppose that angle of force which I am getting in the reaction force, that is in theta direction, and this theta can be resolved in two component. First could be a tangential component, that is ut, that is r cos theta, which will act along this line, r cos theta, and there will be another term will be known as normal component, that is r sin theta. Is that okay? Okay. So therefore I can say that the component ot, which is r cos theta, could be 0. Why? Because the liquid is in equilibrium. That means r cannot be 0. Here it is written that, and hence cos theta will be equal to 0 or 90. So that is, in short, I can say that liquid always exerts force perpendicular to the surface of the container at every point. Suppose you have taken this point. So there will be again, if I get a reaction force in this direction, so there will be again a component theta. It will be again resolved, that is u cos theta and u sin theta, which means that if the liquid is at rest, it will not exert any pressure in the horizontal direction. This is the meaning, and here is the proof that it will have a tangential component and a normal component, and tangential component depends upon the r cos theta, where theta is will be 0 or 90 degree. Now what is the process to measure the pressure? Pressure is nothing but the force, external force upon area up to which it is applying. So measurement of pressure is like this way. Suppose you have taken a wooden block under which a spring is attached to it, and the area of cross section of the this plank is A, and here is the vacuum. Now the force applied is external and the area of cross section up to which you are applying the force. This is the pressure, and don't confuse it with the stress. Stress was sigma, and it is again written there that force upon area. That force was restoring force which the body is going to apply. You have applied the deforming force. In the reaction of that, body has applied stress, which is nothing but the restoring force. So better I would write like this way, that Fs upon area of cross section. This ratio is giving you a stress. It's an internal property. It's an internal property of a body which depends upon the elasticity of the body. Now I'm talking in terms of pressure, which is the force external. Getting my point or not? I hope you are getting my point. So let's move forward. Coming to next topic, what does Pascal's law says? Pascal's law says that a change in pressure which is applied to an enclosed incompressible fluid. Here are the two words, enclosed and incompressible fluid. Is transmitted undiminished to every point of the fluid and the walls of the containing vessel. To understand this, let's draw a figure. Suppose there is a container. This is the container, and here is a triangular object which is kept submerged in this block, in this beaker. So there are the three faces. First is the perpendicular, second one is the base, and third is the hypotenuse. At each face, there will be some force. If I categorically mention that A, D, B, C, F are the faces, and here is the face. So in the face of A, D, E, B, in this face, it's a C. I'm denoting the force FC. If I take a face as B, C, F, E, this face, so there will be an external force that is FA, and if I take this force ACFD, so there will be FB force. Now what does Pascal says that for an liquid, for a fluid which is incompressible, unenclosed, there will be a change in pressure applied at each and every point of the walls containing the vessel that will be equal and equally transmitted to all the faces. So for equilibrium, the fluid element in this case will have the same component. That means there is a slightly marking of theta here and theta here. If I resolve the components, that means each and every force will have a two components. There will be FB, which is at inclined force, and it is a FA, which is also gets an inclined. So all the three forces, suppose these are the concurrent forces. I have told you already the Lami's theorem. So they just cancel each other effective. I told you in the mechanics that this one is theta 1, this one is theta 2, this one is theta 3, here is theta 1, the force F1, force F2, and force F3. So F1 by this will be equal to F2 by this will be equal to F3 by. If I am taking F1, so the angle will be opposite to that, that is sine theta 2. If I am taking F2, which is here, that means I am taking sine theta 3. And if I take F3, that will constitute sine theta 1. So these forces will get cancel out each other's effect, and you get the value which will be equal, because all the resultant will be finally going to show you this result. Thus what does the Pascal says, that the change in pressure applied to any enclosed incompressible fluid is transmitted undiminished to every point of the fluid and the walls of the containing vessel. So here is the proof that FB cos theta will be equal to FA, And for geometry of the figure, we have that AB sin theta will be equal to AC. AB cos theta will be equal to A component. From the above equation, if you want to calculate the pressure, that is force upon area, you get to know that this will be the equation where sin theta gets cancel out each other's effect, and FB upon AB will be equal to FC upon AC, or I can say that this equation could be written in terms of like this. So therefore I can say that force on the face A in the ratio of area of the face A will be equal to FB upon AB will be equal to FC upon AC. This is nothing but showing me that pressure at A will be equal to pressure at B and pressure at C. This is the equation of Pascal's law. I hope you get my point. If you have any query, feel free to contact me. Thank you and Jai Hind. God bless you all.